Hello everyone. Today we're going to go over a presentation we did last month at the Atlanta Gitlab Meetup. We're going to kind of briefly go over some of the stuff we talked about there because we weren't able to record it at the time. And so this presentation was all about security scanning and code quality scanning in the pipeline, and in particular the GitLab CI/CD pipeline. So basically in DevOps, one of the things people talk about a lot is shifting left. And so shifting left basically just means doing things earlier in your software development lifecycle. We know that in security context, fixing bugs, fixing security vulnerabilities, all is much less costly if we do it earlier in the process. So that's one of the feedback loops we're going to be talking about today. In the context of GitLab, we're going to implement some of these ideas in the CI/CD pipeline. And so how are we going to do that? So basically going to integrate multiple tools into the pipeline. It's going to be mostly free tools. We'll look at the list in just a minute. And we're going to do that through most of them are command line integrations. So we're going to show how we do a couple of those in the CI/CD pipeline by taking a look at the YAML. Not all of these things you want to do in the pipeline. For instance, sometimes dynamic security scanning can take a really long time, and I've seen it 12, 14, or longer hours, depends on how large your application is, how many lines of code, how big, how many URL endpoints it has. And so you may not necessarily want to include that as part of the pipeline, or if you do, you may want to include it with some manual steps or just a check on the results or something like that. You may not want to hold up your pipeline, or you may want to do it just on a master branch build, which only happens every so often if you're doing feature branches and development branch as your branching strategy. So what tools are we going to be using for this? Mostly free tools, except for Fortify. We're using that as an example for our static security scanning. If you had a Java project, like one of our other ones we've used, you can use Sonar. OWASP has a Sonar version with find bugs and a couple other rule sets integrated into Sonar that gives you a pretty decent scanning tool for static security scanning. .NET Core is the demo project we're looking at today, and it didn't really have a lot of that built in. So we're going to use Fortify as our example for that. But the rest of these, in addition to Nexus, should be on this slide, are all kind of free. Sonarqube, obviously, for code quality. Trivy is going to be our container scanning. Trivy is a free tool. They were just acquired by Aqua, but they've said they're going to continue to offer that for free. GitLab Community Edition on-prem, OWASP tools, ZAP for dynamic scanning, and DefectDojo for our security console, which is, if anybody's familiar with Fortify and the Micro Focus suites, a lot like the SSC console. All right, so let's take a quick look at our pipeline. As we can see, this one's running. The dynamic scanning just finished and passed. We've done our build, dev, test stages. Our Sonar scan we did in the build stage. We did our dynamic scanning against our test environment. So we wanted to deploy to test before we did that. And right now we're in the middle of finishing out our Fortify scanning and our container scanning. And this is the Trivy scan, and so we'll take a look at what it's doing. And sometimes Trivy takes a little while to download the updated vulnerability database. So that's what it's doing right now. So we're going to wait and come back and take a look at that in a few minutes after it finishes. Obviously, Fortify is going to take a little while too. See how it's going. So it's doing the scan now. You have to do a clean and scan against that. And then it produces a results.fpr file, which can be uploaded into DefectDojo or your SSC console. We're not going to show that integration with DefectDojo today because there's a bug apparently in the upload from Fortify. It didn't seem to want to work. So we're only going to be showing the OWASP ZAP integration. We'll get to that in a little bit. So while that's running, we'll just hop over and take a look at the YAML file real quick. All of this, most of this is custom. A lot of these things have been from documentation out from the different tools. So we're using as a default the Docker executor on our runners. We have custom runner VMs set up, 2 or 3 of those. Here are the stages we saw before. So the Sonar scan is interesting. We're doing that on .NET Core, so we're able to install the Sonar scanner and coverlet for our unit test coverage tool. Able to install that straight onto the .NET container. Makes it easy to run this stuff. And so scroll down, run our test with our collect coverage is true. Open cover format, which Sonar can ingest really easily. Then we run the Sonar scanner with switches for all the different things we want with regards to where the test coverages are. One interesting thing I want to point out is what we're doing with Sonar here is we're not only just uploading the results of the test coverages and the Sonar scan to the Sonar, but we're also using a plugin that plugs into Sonar. It's a GitLab plugin, and if you set up a user in GitLab, get the token, put it in place there in the Sonar plugin for that, then that gives Sonar the ability to write commit messages and merge request messages back into GitLab in line with your code when it finds issues, which is pretty cool because it gives you that instant feedback. That feedback loop occurs much sooner than it would otherwise if you had to go wait longer to go look at that. And it's also easier to have it in line, so it'll point out exactly what lines of code and everything that happens in. In order to do that, you basically just give it the GitLab URL. You send that as a switch with your user token and then your Sonar host. So let's hop over to GitLab and Sonar, sorry. Take a look at what that looks like here. So here's our project. Looks like everything passed. We're showing our test coverage results from coverlet. Notice our version keeps increasing. We're using the version number dot build number to create that version number for us. The version number 0.9 is stored in a variable, and then the rest comes from the pipeline. Not a whole lot going on here. There's not a whole lot of code in this Hello World program. So what we're going to do here is we'll take a look at what the actual inline merge comments look like. So I'm looking at a commit message, a commit with the messages here from the last code update, which basically was adding some of the unit tests. And if we scroll down, we'll see where the Sonar had some issues with some of the code. And so you'll see right here, it highlights the line, makes its comment, and you'll see these same comments in Sonar itself with the results there on the issues. So pretty cool, very helpful, especially if you're a developer and you're committing a lot of this, and you may have this set up on your development branch or even a feature branch you can have the Sonar scanning set up for, and every time you do a commit, it runs it, gives you instant feedback. Much easier to go fix things earlier in the process when you have a fast feedback loop like that. All right, so just briefly take a look at some of the things we're deploying to test. We're doing our smoke tests, as we've seen in previous videos. Scroll down here to where we're doing Trivy. It's very easy. We're using another Docker container. We just basically pull in the Trivy bits, install it, and then we run it. This gives us the ability to also break the build if we want. Trivy, the switch for an exit code. So if we find any critical issues in this particular case, we could say a 1 instead of a 0 for exit code, and that would break the build. It cause GitLab to see that error and then stop. Of course, you would want to make sure that's set to false if you want to do that. If you didn't want to break the build, you could still do an exit code 1, but allow failure to true. Of course, that would just kind of skip that. Fortify scan, we're not using a Docker executor, we're using the shell executor for this. It's a little different. We could have put it in a container, but we just ran out of time really before the demo because we had to quickly switch from OWASP Sonar as our SAST over to Fortify. So what we're doing here is just your basic Fortify source or clean scan, and then we're going to publish some of the results with the FPR utility. You could also then take this FPR file that it produces and upload it to SSC or DefectDojo or something, and go take a look at them there. And then finally, our DAST scanning, we're using OWASP ZAP, and we're using their container image to run that. And we're just doing a quick URL with the zap.sh. Export it to an XML file. So then we're just basically, after we run that, we're posting it to DefectDojo with a simple curl command, Perl command that contains a curl command, which had to do that because the GitLab, the scripting interface here was complaining about some of the characters. And so in the essence of time, we decided just to stick that in a Perl script. Could have easily been done in a bash script or something else too. So we're just doing a post. We're doing a post here to our DefectDojo API endpoint, import scan. It's running in a Docker Swarm cluster, so that's the name of one of our Docker Swarm hosts. We could put a pretty URL, but we didn't. So here's the file we're uploading, the report.xml. We tell it what scan type. It's a ZAP scan. Make sure we tell it what engagement it's for, and it sucks that in and gives you the results. All right, let's take a look back at our pipeline, see if we're done running yet, where we're at. Okay. So we're blocked. So what does that mean? Looks like we ran all of the scans and everything, and they're all green, so that's good news. In this case, this is an example of we have manual approval that maybe there's a security steward or somebody that business steward that needs to review the results of the scans before they're going to approve deployments to production. So we have a step here where we email these people, they get the results, they go look at them, maybe in DefectDojo or whatever security console they have. And once they agree, they come in here and they click go for the review. So we can click play. And then we'll kick off the rest of the pipeline. So while that's going, we're going to go in here and take a look at what did our dynamic scan output look like. So looks like it timed down in this particular case because I think my test environment is running a little slow today. But it's what it would look like when then we upload the results to DefectDojo. That's really interesting. We'll have to find out what happened there. The Fortify scan results, we're going to do a quick. It's going to tell us how many issues it found. 65 issues, all of them key management hard-coded. And so this also, everything we're doing in this pipeline, we're uploading it back in the GitLab as an artifact, so you can download those manually if you want, if they're not being uploaded directly into a security console. All right, so we're moving ahead with our production deployments. Everybody's happy. While that's doing that, let's hop over to our tests. Let's go take a look at our test app and see what's going on here. We need to go to our demo test project in OpenShift. That's where we're hosting our dev and test environment. Hello Core, that's the one we're doing right now. Number 45, looks like it's running. Hello Core test, let's see if it's up. And it is up. So maybe it's just running a little slow with the DAST, which is really cool. So what we could have done here, in this particular case, if it If it failed, we could have told it to give a switch and break the build, same way we did before with Trivy. And so that could have let us know our smoke test for this particular one. We'll go take a look in DefectDojo and see what it looks like. So it looks like we've deployed to AWS now. It's going to go to Azure. Hopefully everything's kosher. So for DefectDojo, this is a security console idea, very similar to SSC. It's open source, put out by OWASP. We can see we got 1 active engagements. Here's an overview of what it's found. These are all just going to be the OWASP ZAP. That's the only thing we have imported right now. So let's go take a look at products that we have. We should just have 1 product in here. Well, I actually have 2. But we're going to take a look at Hello World Docker, which is one we were just running our scans against, and you'll see it had 15 total findings. Let's go take a look, see what the actual open findings are. And then give us a list of everything ZAP found, which is kind of neat. And then you can go in here and type in your responses to each one of these, make your security people happy, put in your comments, resolve them. You can even click on CWE to go read up on what that vulnerability is. So it's a pretty handy tool, again, for free. So you can't be too upset with that. All right, looks like our pipeline's done. Everything's deployed and fun. This little external thing gets inserted from Sonar integration, actually. So because we had that integration with the user, and it had the write back capability back into GitLab, it adds this little extra step to show that that ran, and shows kind of giving a tooltip for the findings. All right, that's pretty much it for the quick and dirty overview of the presentation. Anybody has any questions, shoot us a note, post on the comments on the blog. Thanks, and everybody have a great day.